Welcome to the first project video on this channel, the amazing electric skateboard. This project would be divided into three parts. First episode would be based upon the remote and the receiver. The second episode would be based upon the skateboard itself, the ESC, the motor, the battery, everything. And the third episode would be the most crucial episode, that will be the real field test. It will prove that our skateboard is practical and is working as expected. Also, I'll try to keep most of my projects to be open sourced except a few, and all the viewers are really welcome to collaborate and contribute to the projects. All the project resources would be provided to you through the GitHub links or the Google Drive links. So stay tuned for more. So this is a remote and I needed some rugged and sturdy look, and hence I designed this military grade enclosure. Now let's have a look at how does this thing works. First of all, we have the modest USB type C port down here that is used to recharge the battery and also update the software for the remote. Secondly, we do have an OLED display module here that will show us the speed mode, the reverse mode status, the battery percentage of our remote, and the connection status as well. After that, we have a self-returning joystick module here that will be our throttle for the skateboard, and we have a push switch here for changing the speed modes and a slide switch here to change the reverse mode on and off. Now on turning the remote on, as you can see, we are on the Eco Plus mode as of now. When we push the throttle in forward direction, it goes to a total of 50% of the total power. Similarly, in Eco mode, it goes to a total of 70% of the total power, and in Beast mode, it goes to 100% of the total power. Similarly, when we toggle the reverse switch here, we find that we on pushing the throttle backwards on beast mode, it goes to 100% of the total power, and similarly in Eco Plus and Eco mode, 50 and 70 respectively. And if we need to apply the brakes or cut off the power to motors, we just need to push this joystick module button downwards here, and our speed will immediately become 0. So this can be used as braking system or turning on the brake lights that we'll be adding in future enhancements of our skateboard. So these were all the features of the remote. Let's go inside this remote and see how all the components are connected to each other. To enable both charging and firmware updates simultaneously, we'll use the two male micro USB ports and one female type C port. The port connected to the ESP32 will have both its power and data lines connected. The second port, which is used for charging, will only have its power lines connected to avoid any data interference. For real-time remote battery monitoring, we'll reverse engineer a 1S battery capacity indicator module. We'll remove the LEDs and route the positive terminals of each LED to 4 GPIO pins on the ESP32. All negative terminals will be tied to a common ground. This setup allows us to determine battery levels based on the number of high signals received. One active signal indicates 25% charge, two indicates 50%, and so on. As for the joystick module, we'll only use the X-axis for forward and reverse motion and utilize its built-in switch for braking functionality. We'll also include a slide switch to toggle reverse mode and a push button to cycle through speed modes for better control. Regarding the power setup, the battery terminals will be connected to the output pins of the charging module. These same lines will power the ESP32 through its VIN and GND pins. Lastly, we'll add a slide switch on one of the battery terminals to act as a main power switch for the entire circuit. Now coming to the receiver side, this part is relatively simple. It consists of just the ESP32 board and a bidirectional 5-volt level shifter. The slave ESP32 communicates with the master using ESP Now, a low latency peer-to-peer communication protocol specifically designed for the ESP boards. All control signals such as PWM for throttle, reverse direction, and braking are sent wirelessly from the master to the slave. Since our ESC requires 5-volt logic signals, we use a bidirectional level shifter to convert the ESP32's 3.3 volt output up to 5 volts. This ensures compatibility and reliable signal transmission to the ESC. Now here's the actual demonstration of how does the skateboard works with this remote. So in the forward mode, if we are on the eco plus speed mode and push the throttle forward, then our motors rotate in the 50% of the total power. Now if we change the speed mode to eco, it'll be moving at the 70% of total power, that is this much. And similarly, if we go to the beast mode and push the throttle forward, it'll be rotating in the full power. And now if we toggle the reverse switch here and push the throttle backwards, it will be rotating in the reverse direction. This is the beast mode. When we go to the eco plus mode and pull the throttle backwards, it will be rotating at 50% of the total speed. Similarly, in the eco mode, it will be rotating at the 70% of the total speed in the reverse direction as well. Now if I want to demonstrate the safety feature, I'll just go to the beast mode and pull the throttle fully backwards. Now, for example, due to any reason our remote gets disconnected, or if it gets discharged and it turns off just like this, then our skateboard stops working immediately, preventing any injuries or mishappenings. An ample amount of time was consumed in the coding part, as coding is something where I don't shine much. I've already added links to all the codes down in the description. You can check them out. And talking about the 2 other remaining episodes, they can be delayed a bit because of my ongoing internships and projects, but better late than never. I'll surely upload them. This was all about the transmitter and receiver of the amazing electric skateboard. I hope that you have liked the way how I demonstrated everything in this video, and also hope that you have learned something new. Thanks for watching.